Hello everyone, my name is Hong Yipan. Today, please allow me to introduce Fourier domain pruning of mobilenet-v2 with application to video-based wildfire detection. I worked this project with Dia and my PhD advisor Professor Chitton, and we are from the University of Illinois at Chicago. This is today's outline. First, I will introduce mobilenet-v2 for wildfire detection. Then, I will introduce Fourier transform-based neural network pruning. Next, I will discuss block-based image frame analysis. Finally, I will show some experimental results and make a conclusion. In this text, we use transfer learning on mobilenet-v2 for wildfire detection. mobilenet-v2 is a mobile CNN published by Google in 2018. It is a low-cost network, so it is very suitable to run it on NVIDIA Jetson Nano. In our training datasets, there are totally about 10,000 training images, and 3,000 of them are wildfire images. All of them are reset into 224 by 224, which is the input of our network. Some training samples are here, so you can see. Next topic is Fourier transform-based neural network pruning. The goal of it is to make the network smaller and faster. How do we achieve it? We extract 3x3 convolutional kernel weights and calculate their Fourier transform. As shown here, you can see some kernels has totally zero response, so we just remove them from the graph, because we treat this as a death neuron. Moreover, we eliminate those kernels with low energy at the one-by-one convolution layer and the dense layer. Another thing is that when we perform 64x64 FFT, we found that some kernels have very similar response. You can see these two kernels, the response are very similar. So we use cosine similarity to measure which two are similar. The cosine similarity is the product between two vectors divided by their norm. And we treat those kernels with similarity larger than 0.99925 as a pair of similar kernels and slow only one of them, and we can reconstruct another one based on it. This value is chosen based on non-fire video test experiment. And in this way, about 22% kernels are removed. The reason we use the Fourier analysis instead of time domain analysis is that a kernel with its shift kernel may have a very small cosine similarity, but their frequency response will produce a cosine equal to 1 or minus 1. So in this way, we can find which two are similar efficiently in the Fourier domain. By running the interface 100 times, we found that we can save about 7% time. Here's a graph to show the network before pruning and after pruning. You can see that the network is smaller than before, so we accelerate the network. Next topic is block-based image frame analysis. So nowadays, surveillance camera are in very high resolution, but our network has the input 224 by 224. So if we just downsample the high resolution frames into this small resolution, then we will find that the small smoke region will be totally invisible. So this is not a good choice. How do we overcome this problem? We divide a whole frame into many small tiles with overlapping. For example, the 95% score is the possibility of smoke or fire in this region. So we test our system on H3N dataset. The H3N dataset is developed by UCSD people, and you can see that our system can detect fire timely with very low accuracy, with very low false alarm rate. And also, if we prune it further, we can see that the false alarm rate will increase. So this is not a good choice. So that's why we use this value as the pruning threshold. Here are some samples, and here you can see the fire, the smoke is very small, but our system still managed to detect it. Also here, and we compare with other state-of-the-art works on BOW fire dataset. You can see that our system can reach very high accuracy. And it is worth it to mention that these two are labeled as no-fire, but actually they are fire images. But for a fair comparison, because they are not mentioned in these papers, we just count them as false alarm cases. But if we count them as true detected cases, then our accuracy will be higher. So that's all for today. Let's make our conclusion. We trained a neural network for wildfire surveillance test while transfer learning, and we prune it by Fourier analysis. We use block-based image frame analysis to capture small smoke regions, and we test our system on H3N dataset and BOW5 dataset, and we obtain very good results. So that's all for today. Thank you for your listening, and let me know if you have any questions. Here is my email. Thank you.